we'll get going here. So no comments on how the homework was. So ultimately, I want to finish up 1.6 today. So that'll be due. We don't meet on Wednesday. So we're going to have the evens that I assigned from that are going to be due on Thursday. Hopefully I can get into 1.7 today. But what I want to do is I want to give you a quick quiz. I want you to not really use your book and notes if possible. I'm going to try and watch you if you put me on there. But anyway, we'll see if John's getting on here. Oh, he was in a different classes collaborate.
Yeah.
That wouldn't be as fun. So anyway, as soon as he gets on, I'm going to give you a little pop quiz, so no big deal. And then what you're going to do is you're going to have, I'm only giving you 5 minutes to do it. You're going to, when you're done, you're going to text me a picture of your work. So just give you a little heads up. So normally I would have done this in class a while ago, but since I haven't been in there with you, I haven't done that. So anyway, and I did communicate with Pete as well. Pete realizes that we're still remote presenting. I did tell him, as long as you got earbuds or whatever, if you'd rather be in the library or whatever, just the library or the room's probably easier in case you do need to ask questions or talk out loud. That would be easier. But if you have earbuds and for any reason you feel it'd be better to be in the library, that's fine. You just got to let me know if you're not going to be in the classroom. So when you're able to be at school. So all right. So is he on yet?
Yeah, I'm on.
All right. Perfect. All right, so John, we're waiting on you because I want to give a quiz. So this is exciting. This is where it gets real, and we're going to find out what you know without looking it up. So you got 5 minutes to do an epsilon delta proof for me on a piece of paper, and then you're going to text me a picture of it. So here's the problem. The problem is, so we want to prove that the limit as x approaches 3 of minus 4x plus 5 exists and equals -7 using epsilon delta. So it's a proof. All right, you got 5 minutes. Go. Got about 30 seconds. Okay, I got some pictures coming in, so everybody else, let's stop and send me what you got. I gave you 6 minutes on that. Where's the other? Oh, you guys are sending by WhatsApp, and that WhatsApp is fine. WhatsApp or wait a minute. You guys are sending it to everybody. Luke and Isaac, you're giving everybody hint, but that's right. Just go ahead and send what you got, and then we're gonna look at this. What I'm gonna do is I'm gonna actually put my solution now on instead of going through everybody's now. Ultimately, you should be able to do a problem like this in about 5 minutes. So without thinking too hard about it. If not, then maybe you don't know the theorems quite as well, or the process quite as well as maybe you should. So let me. All right, I'm gonna send mine. So if you just want to look at the WhatsApp right now, long story short, so I just sent. So hopefully everybody can see it. If you can't on WhatsApp, let me know. But my key. So the first thing that we need to do is we need to show that it is defined on some open interval containing x equals 3, except possibly at 3 itself. Well, the domain is all real numbers for the function that we have. So I'm going to use a different color. But here's our function f of x, and the domain of that is all real numbers because it's a line. So we're fine there. And then we start out, and the left side of my key is the scratch work, and the right side is the actual proof. So I did my scratch work first. I said, let epsilon be greater than 0, and we need to find that delta greater than 0 such that 0 is less than the absolute value of x minus 3 is less than delta, implies that the absolute value of f of x minus L. Well, f of x is minus 4x plus 5, and then minus L is minus a minus 7. That becomes a plus 7, is less than epsilon. And then what I do is simply continue working with the right side and try and get something in terms of the absolute value of x minus 3. So I'm going to keep working with that, simplify it. I can factor out a minus 4. If I factor out a minus 4, that leaves an x minus 3. If all I did was factor out a 4, it would be 3 minus x, not x minus 3. And then, of course, the absolute value of 4 times the absolute value of x minus 3. The absolute value of minus 4 is 4. And so anyway, the absolute value of x minus 3 ends up being less than epsilon over 4 on the left side. So that's my scratch work. And ultimately, because that's the right half of the first inequality up there in my scratch work, I'm going to set delta equal to epsilon over 4. So then on the proof, I've already showed it's defined. So basically it's just let and set. Let epsilon be greater than 0, set delta equal to epsilon over 4. Then we just continue that process. I kind of ran out of room a little bit. Then 0 is less than the absolute value of x minus 3 is less than delta implies we just take the right half of that chain link inequality. Absolute value of x minus 3 is less than delta, and I replace the delta with the epsilon over 4 that we came up with. And then what I do is I take the left side of my scratch work and I just work back up that work. And so I get the 4 on the other side and call it absolute value of negative 4. And then I put it inside and then I split it back out. And then I've got, I end up with the absolute value of minus 4x plus 5 minus a minus 7 is less than epsilon. Therefore, we just proved for any epsilon window and that delta that the limit as x approaches 3 of minus 4x plus 5 exists and equals minus 7. So who thinks you got that 100% right? Anybody? And if not, you can chat that if you think you got it right, and then I'll look at it. I'm going to guess almost everybody forgot to say the domain is all real numbers. You forgot to show that it's defined on some open interval. So I just wanted to do this to you. Usually I do this and grade it as like a 5-point quiz, but I'm not gonna grade this one. I just want this to be an alert to you. Either A, yeah, I feel pretty comfortable on how to do this, or B, no, I don't, or C, well, the negative numbers confuse me on this one, but the rest of it's pretty good. So anyway, we'll go on. Is there any, hopefully there's no other questions in 1.4 and 1.5. You guys were finishing that up, but then I guess if there is, let me know. But on 1.6, we were looking at one-sided limits, right? And a lot of times with split functions, we're coming up with that. So I'm going to go back into the one-sided limits, and we're going to go back to the one that we were looking at, and then I'm going to do an epsilon delta. So I'll give you a little break on the epsilon delta here. But number 31 was one that we were looking at. And number 31 had basically, if you want to open your book to that, it had a split piecewise defined function, and it kind of looked like this. So it was a parabola coming into so it's x squared until we hit -2. So for x less than -2, and then we had a line, and x equals 2. By the way, this was up at 4. And then we had a line at 2, -2, from there off to the right. And what we wanted to do is we wanted to figure out the line in between. The red line is ax plus b, where -2 is less than x is less than 2. And the question is, what do we need for A? What do we need for B? So now hopefully everybody can see me drawing on the whiteboard here. Looks like I am recording this section, so that's good. So the question is, how are we going to do this? Well, if I want to look at the left-handed limit coming into -2, I know that the left-handed limit, let me just do this down here. I know the left-handed limit for x equals -2, I'd be coming in on this one here, right? So actually would exist and equal 4, correct? So if the limit at that point is going to exist, I need the right-handed limit as I come in. As I come in on this line, I need the right-hand limit to exist and approach that open hole. So the right-handed limit also needs to exist and equal 4. Okay, so of course the left-handed limit is going to be the limit as x approaches -2 from the left of x squared, because that's where I'm at. And of course, that does equal 4, right? So the question is, what's the right-handed limit? Well, the right-handed limit there is going to be the limit as x approaches -2 from the right. So I'm approaching -2 from the right here. And the function that I'm on there is ax plus b, and that needs to exist and equal 4. Because the left-handed and the right-handed limits not only need to exist but be equal for that function to have a limit there. So anyway, we can just plug in -2 here because this is a polynomial function, right? So if I plug in -2, I come up with the equation -2a because I plugged -2 in for x, right? So -2a plus b equals 4. So I have, if you notice, to make this, the question is you want the limit from both sides to exist. So this is what we have to have. So we have one equation, but we do have two unknowns. So I have to do this again on the other side. And coming in from the other side, I'll use purple here. But as x approaches 2 from the right, the height here approaches -2. So for the right side, the right-handed limit would be limit as x approaches 2 from the right, and the function that I'm on there is 2x minus 6, and that's going to exist and equal -2. So we know that one, but we also need the left-handed limit there. I'm going to use orange because it's pretty similar in color. But as I approach that from the left, I need to also have my graph approach this open hole, which has the same height. So the left-handed limit, I'm going to go here for the, as x approaches 2, the limit as approaches 2 from the left of f of x, and in this case, I'm on ax plus b. That also has to be the same height as the right-handed limit so that it exists. So it has to equal -2. Okay, this was -2 here on the right. So for the height that we're approaching from both sides. So here I can just plug in 2 in for x here, and I'll end up getting, I'll come down here, we'll get 2a plus b equals -2. And so for both the limits to exist where those functions connect, I have now two equations and two unknowns. And so anyway, long story short, we just need to solve this. There's a lot of different ways to solve two equations and two unknowns, right? So this is one way to do it. So basically what I'm going to do here, I'm going to rewrite this underneath. This works out nicely because the a's have the same coefficient with the opposite sign. So if I add these together, what happens? The a's go away, and I'll have 2b equals -2 plus 4 is 2. So that says that b equals 1, correct? And then I can go back into either one of them and resubstitute that back in. It looks like it's a little easier there. And if I plug in to that one, I'm going to get 2a plus 1 equals -2. So where can I write that at? I'll go up here. 2a plus 1 equals -2. Subtract 1 from both sides, so 2a equals -3, which says that a equals -3/2. So for my a and my b, I'm going to have -3/2 x plus 1 is actually the f of x for the red function when I'm between -2 and 2. So that would allow that graph to connect here and hit the same height there that the other ones are approaching. So that's one way to solve that. Does that make sense to everybody? I see there's a couple chats. So anyway, there is another way to do it. I'm going to show you one other option on this that a student did, which actually works out. So without really taking time to draw it nicely, I'm just gonna, we have this here, and we had this here, and then let me get back here, and then we have this line connecting them. It doesn't go through the origin, it's actually above the origin. But anyway, that really doesn't matter. But we know that the point on the left, that hole, is minus left 2 up 4, and we know the hole on the right is right 2 down 2. The other thing I could do is, because I know that that has to be the height here, I could use the good old y equals mx plus b formula to come up with the equation of a line. And what I can do is figure out m by using a slope. So to come up with slope, I have 2 points. So I can say, you know, change in y over change in x, delta y over delta x, or y2 minus y1 over x2 minus x1. If I start with the top one, it'll be 4 minus a minus 2 over minus 2 minus 2, right? And that ends up being, the slope is going to end up being 6 over minus 4, or minus 3/2. And then once I have that, I can plug that. Oh, that's not x, that's m. So I did not mean to circle the x, I meant to circle the m. So that's the m. We can plug that in up here for the slope, and then I'll have y equals minus 3/2 x plus b, and I just figure out what b is. Well, I can plug in either one of these points here. So what I could do is I could plug in 2 for the x, and I could plug in minus 2 for the y, right? And then figure this out. And if I do that, I'll get minus 2 equals minus 3/2 times 2 plus b. That cancels. Add 3 to both sides, and we find out that b equals 1. And then, of course, that plugs right back there into that. And then we come up with the equation of the red line again, using it this way, is minus 3/2 x plus 1. And of course, you could also use the other y minus y1 equals the slope of the line times x minus x1 to come up with the line. But they specifically had that function as in the y mx plus b or ax plus b formula. So really, instead of m, they were calling that, they were calling m, they were using that a instead of m there. Anyway, 2 different ways to solve number 31. I know you have to do number 32. That seems to be a stumper at times for students, so that is a good method there to use. Let's look at number 35. Once again, this is going to be a lot easier if you are looking in your book. And so I'll try and sketch it out here too, just for the recording purposes. But what we have is we have -1 here. We have a line that goes up to 3. It's a solid dot up here. And then we're at the origin. Then we go up to 5, and that's filled in. So up here at 5 when x equals 2. And then we drop down when x equals 3. We drop down to a height of 2. Whoops. So that's a line there when x equals 2. And then we have a dot up here. So we actually have a height of 4 here for when x equals 3. And then when we get out to 5, we connect to here. So here's kind of the picture they have for number 35, and then they have a whole bunch of questions. The domain of this function, this is a function because it passes the horizontal line test, vertical line test, right? It's not a one-to-one function because it doesn't pass the horizontal line test. But anyway, it's looking for some different limits. So I'm gonna, let's see, we're gonna go around the room. I'm gonna, whatever room you're in, Carter, I'm gonna make you start What is the first one? The limit as x approaches -1 from the left of f of x. I think I'm reading that right. I don't know if I can read it right because I'm not wearing my glasses today. From the right, -1 from the right. So the limit as x approaches -1 from the right of f of x. What's that equal, Carter? Right there. You can either talk or chat it in. See here? 0. That is correct. Okay. So once again, I'm going to use try to use different colors here. But as I approach -1 from the right, my graph approaches a height of 0 there, right? So so that's the right limit at -1. Number B, we'll go to Hannah. Hannah, it's looking for the limit as x approaches 0 from the left. Limit as x approaches 0 from the left of f of x. If I say it wrong, let me know. As I approach 0 from the left, yes, correct. It is 3. As I approach 0 from the left, my height of my graph approaches 3. So it exists and equals 3. So that's right there. And then Kylie is hidden from my list. She gets to be next. The limit as x approaches 0 from the right, Kylie. Correct. So as I'm coming into 0 from the right, my graph comes down. So it's kind of easy to come up. So I'm approaching that open hole. Remember, limit, you can get as close as you want without touching it. So x never actually touches 0 here. But anyway, this does equal 0, which is what I think he said. Yeah. Oh, that's nice. You put in her name for it too. And then Isaac doesn't look like he has much of a signal, but what's the next one? Limit is x approaches 0 from both sides of f of x. What's that, Isaac? You guys didn't know I was going to call on you, did you, during the remote sessions? 3, okay. Well, anybody else chime in there with something else? If you notice, the left-handed limit and the right-handed limit do both exist, but they're not equal. So the limit from both sides, this is from both sides, right? So we actually have to say this does not exist. Yep, correct. So this does not exist. Correct. Okay, so now what's next? The limit as x approaches 2 from the left. X approaches 2 from the left, 2 from the left of f of x equals, let's see, who's next? Jack. 5. I like it. Okay, so it equals 5. As it approaches 2 from the left, I'm sliding up there toward that dot there, so that equals 5, correct. And then the next limit as x approaches 2 from the right. John. As x approaches 2 from the right, what height are we approaching? We're still approaching 5, right? So limit as x approaches 2 from the right of f of x equals 5 as well. Therefore, let's see who's next. Jordan, what would the limit as x approaches 5 from both, or excuse me, 2 from both sides be? Also 5. And that's because the right-handed limit and the left-handed limit both exist and are equal. Absolutely. Okay, and then we got, let's see what their next question is. They have a trick one in here somewhere. I have a trick one. This isn't one of the questions, but Luke, what's f of 3? I'm going to use a different color here. I'll use red. What is, this is a question that's not in the book. What's f of 3? Okay. Well, f of 3, it's hard to say, but that's just what's the height at 3. So that's really, it actually, this is the height when x equals 3, right? So my picture is a little bit confusing, but if you look in the book, it's the height. This is nothing more than the height when x equals 3, right? And so that would be the height of 4. It's actually defined and solid right there. Okay, it has nothing to do with the limit. It's just the actual height. So hopefully that makes sense. So let me go on to the next one. It is in the book. They're looking for the left-handed limit at x equals 3. We'll go back up to Carter. Limit as x approaches 3 from the left of f of x. What's that one equal? Luke might have been answering this question. Yep, this is 2. Okay, and then who's next? Hannah. Limit as x approaches 3 from the right. Also, as x approaches 3 from the right, we approach that open hole as well. So once again, you got to have limit of, you got to have of f of x. But anyway, that's also 2. So then, this should be easy then. What's, because these are the same, what's the limit as x approaches? Yes, from both sides, correct? And then last but not least, we've got, well, 2 more. We've got the limit as x approaches 5 from the left of f of x. What's that one? Who's next? We got Isaac. As x approaches 5 from the left, 0. Okay, now I got a trick question. First person to answer wins. What is the limit as x approaches 5 of f of x? Isaac wins. Careful. Isaac and John are both correct there. That's our 2-minute warning. It does not exist, right? So the limit as x approaches 5, that would be from both sides. Well, the left-handed limit is 0 right here, but the right-handed limit doesn't exist. There is no function. There's no function to slide in on toward that. So the left-handed limit doesn't exist. Therefore, the limit from both sides does not exist. If I would, what's the right-handed limit as x approaches 5? That would also not exist. But from both sides, it doesn't exist because the right-handed limit doesn't exist. So hopefully this helps. I didn't see that there was any other questions there. Thanks for participating today. You know, really, I like the hour sessions or 55-minute sessions better because we can kind of get into a groove. So try and have the evens for 1.6. Make sure you're doing the odds that are similar. Ask me questions. I am done with everything except the epsilon delta. I do want to just show that for a right-handed limit. If I'm looking at the epsilon delta, well, if I'm only approaching from the right, then what happens? Basically, instead of saying 0 is less than the absolute value of x minus a is less than delta, I don't need to do that, right? So the absolute value of x minus a, if I'm approaching only from the right, and this is my x here, or my little x's, this is going to be a positive number. So I can just say 0 is less than x minus a, which is less than delta. And then that would imply, whoops, whoa, get that out of there. I can just write x minus a. I don't need the absolute value around that. So that's the right-handed limit there. If I only approach from the left, so just give you a quick, so here's a, I'm approaching the height of L, but the left-handed limit, instead of having 0 is less than the absolute value of x minus a is less than delta, basically, as I come in from the from the left, my x is less than a, right? So if I subtract, I get a negative number. And to take the absolute value, this would be negative in there. To take the absolute value, I'd have to take the opposite sign. So I'd have to take the opposite of x minus a, which actually becomes a minus x. So instead of having this here, we're going to have 0 is less than a minus x is less than delta. And we do not need absolute value signs then because we've already done that. We know x's lie below a, so a minus x is going to be positive. Now we still have to have the absolute values around f of x minus L is less than delta, or less than epsilon in both cases, because I could be approaching from above or I could be approaching from below, so we don't know which one's bigger without the picture, whether f of x is bigger or L is bigger. So we do need the absolute value of the second part of this. But anyway, there's just a slight adjustment on the epsilon delta. And then now I'm going to finish up. 1.7 is infinite limit. Make sure you read that as well. Try and have the evens done for 1.6 if you can, but make sure you got the odds and bring any questions to me. And then 1.7, read that and see what you think of that. And we'll go over that on Thursday. Take care, everyone.